So first and foremost, we go to date. In Python, or generally, we call it Python date, and the date is not just a data type of its own. So we can import the module name datetime to work with dates as date object. So for example, you can import using your Python to know the current date on your laptop, depending on either laptop or whatever you're using. So you go with datetime, and let's say that we are going to say that datetime. So I'm going to copy this datetime just to paste it here, and I will say dot datetime dot now. So with this, and I can say print a. So let me go ahead and run this. So give it a minute to connect. Yeah, some seconds is connecting. Alright, so when it's finished connecting, so we can go ahead and run. So it's connecting, it's connected. So this is example you see here. So based on the time on my PC, so you have the time which we automatically pick the day and time. Now this is daytime. Now I just imported daytime, and then I say daytime and now, and it's going to read and give me the time in the day, the time, the minutes here, and then also the seconds here. So this is the time it shows me here. So this is the way I can import a daytime and should be able to use that. At the same time, when you put that, you are going to get the result, and that is going to contain like the year, the month, the minutes, the seconds, the milliseconds as time. So you can see the year, the month, the day, the time, that is in hour, the minutes, the seconds, and the milliseconds as well. So this is what it shows you here. So the datetime module have many methods of returning information on the object. So there are several ways you can actually put them in. Example of what I am saying are several ways is, let me just copy this and make a modification on this. I'm going to paste it here. So I'm going to make a modification. Now for me, instead of me showing this, I can say give it to me as year, for example. And when I run this, I'm going to have 2025. So this is going to give me the year. And at the same time, I can also get this done by bringing this up here, and then I will now say year, which is the year I want, and I'm going to say something like, we call it here, it is an inbuilt function here. You can see it here. This is second, and this is SRTF time, so which we use that. So we call on this, and you can also say give it to me in the tab of A. So this is going to show you in this particular one. So it is called a straight time. So it's going to tell you today is this, and the date and that's related to today is Monday, and this is going to give you the dates of the week. So you can see here that we have this, and A is gives you in this. You can also use the same thing in creating object. How do I mean by creating an object? Example of what I mean by creating an object is, I've already imported the date time. I might choose not to use it. What I mean is that I can remove this because I don't need that again, so I can continue with what I have. So I can also make it, instead of me making it now here, because of the now that I put there, and that's how I'm able to have the date now. So let me say that I am putting 2025 and 11 and then 17, yeah, and then you now go ahead and say to print you this. So I'm going to remove this. So let me run this right now, and then you can see here that we are having them as this, and in this time pattern. So you have this .000 at so you can use it to create an object, and also this gives you the time zone. So as you put it here, it takes in and then return the default value of the time zone, which is 000, based on the time zone on where you are. So in general, when you are using the SRTF, so which we use, so we call it that is STRF time method. So this automatically, it is called the method. We call it that it takes the parameter format and then specify the format which is going to return. Now another example I'm going to use here is, let me copy this as well, and then when I paste it here, and when I paste this here, so I'm going to say print a dot from what I did here, and I'm going to say this one here, and I'm going to say put it in this format, and I'm going to say double parenthesis percentage, and then I'm going to say b. And when I run this, what is it going to give me? It's going to give me the month as related to this, as you can see here. Now to explain this particular thing, now let me give it to you one after the other. Now the first thing here, when you go ahead and say copy, and you are trying to bring in the time, for example, and you use here small a, so this try to tell you the short version of that week. So this you can see here, November in capital. Here I put small a, it shows me the day of the week. But if I put small a, it shows me the small version. If I put capital A, it shows me the complete version of the time of the week. Now this is just the difference between them. This shows you the small version. This other one shows you the complete version of that particular day you are referring to, the time of the week, as you can see there. So if you put a small version, it shows you that. If you put the big version, that shows you the bigger part of that particular one. So as you can see here, this is smaller, and if I put the big one, it shows me the bigger one. So if I copy this and put it up here, and then put the small one here, and that shows me the small part of it. So if I run this, so what happens? Then it shows me in small letter. So capital, small letter, and this one shows me in this particular pattern. So if we also want to also visualize something like the week, so we go ahead with this pattern. So I'm going to copy this, and then I'm going to paste it here. So in this way, instead of me using a, so I'm going to use small w, and when you run that, and that's going to show you one, which symbolizes now the weekday as the month between 0, that is to 6. 0 is 6, so it shows you the weekday. So today is Monday, and it's showing you 1 here because it starts from the beginning of that way. So you can also try using the d, which is trying to tell you which particular day of the month. So if you want to get the dates, the d here means the date. Then when you also use the b aspect of it, just like you remember the way we use the capital B, so if you use the small b aspect of it, so it gives you the short part of the year as related to that. 1 second please.
Just give me a second. I'm going to, there are some people whom I want them to work together.
Sorry, I'm still in the meeting. I wanted to know what they're saying there. All right, so this is when you want to get the short form. So these are just a short format of how you can access some data. So in this one, if you go to B in capital letter, like I used earlier, so this is going to show you the November. Anytime you put this, that's going to get you the B in short letter. So if you want to access the month, to know what the month is, you are going to use M, which is going to give you in this particular format. This is 11. The small m thus shows you in month. And then if you want to access year, like we have said, I have showed earlier, so you use y in this particular format, and that's going to give you the short year in small letter. But if you want to get the full aspect of it, then you are going to use the capital Y here, and then you run it, and that's going to show you in capital letter. So if you want to see something that related to hour, like the way we are saying this, what is this thing, you use H. So it is a keyword that it already understands. You can see the hour comes in 00. And then also, if you want to see the hour as well in the aspect of the hour, that clock, so you use this thing here, and then when you run it, then you should be able to have it in this particular pattern. So if you are putting it in that way, so you put it percentage of that I in capital letter, sorry, so that's going to give you in that in this order here. So you can see it here. So that's going to give you by 12 hours as it is. So if you want to also see the time that you are working on, or whether it is morning or evening, so you use the small p like this, and when you run the small p, what happens is that it gives you in AM or PM depending on the time that you are looking at. So generally, if you also want to use seconds, you use S. If you want to see milliseconds, you use milliseconds, which you are going to use F. But if you also want to check the time zones that you are working on, so the time zone, we always use Z, which is always 0. This is the time zone. Now, this is the time zone you are working on. You can see here that this is going to give you the time zone you are working on. Then if you put it on this is on the CST, then if you put it in a small letter like this as related to time zone, so you run it, and that's going to give you the time zone as related. So sometimes when you see a time that shows UTC or sort of things like that, so this is a way you get that done in terms of time zones. Then you can also use U as well to get the week. Like if you run this, you can use it to get the week. So we are currently in week 46. You are going to get the week as related, the week of the year, then as related to this. So if you use U, that's going to give you that. Then if you use W as well, so if you want to see the local time of the date, so you are going to, so these are different ways you can do. So when we get into this, you can see implementation, so you will be able to understand which ways can you use time as well. So if you put it in C, you're going to get it Monday, November 00, the same way in that particular pattern, and that's how you can get a local version of the time you are looking at. It's going to come in that version. If you want to see the century we are, then you use capital C in order to get the century of the time that you are. So that's going to give you the century. So for now, we're in 20th century, as you can see here. So we get century. If you want to get character, if you want to get the ISO date, you now use G. If you want to get the time of week, day, so there are different versions you can use time. But the whole thing is that when it comes to using of time, you use import date time. Like assuming you want to run a particular program and you want to know the time, you can use the time that you want to have on that one. So because that's the only way you will be able to see the time you are using and have access to time. So that's why we import. Now remember that we're moving into what we go to use modules. The first thing you remember here is that I imported date time. So we are importing. So when it comes to importing, you import and you'll be able to use that time. Like if you look at the code, what I use here on the code, what I did here was I imported date time. Why? Because I'm interested in knowing the time I am going to. You can see here, I executed the date time now. Anytime this code runs on its own, like for example, if you are looking at the code, so what happens is that because of import date time, that's why it is able to read and know the time that it is going to run, what time is it acquiring those things, what time is it getting that. So like if you look at this code now, if I run this particular code, for example, you can see it automatically picking up the time that I have and start working on those time. That's why I decided to use from date time, import date time. So I am bringing importing the date time, and I'm also importing the date. That's why if I run this particular code, you will be able to see that here the first thing is going to read it like this, and the next thing is going to check is what time, and it's going to get it. That's why you see that it is collecting this data. You can see I have collected the date, picking the date, and from here it is going to store these data in the path, also including the based on how I actually run this states that this script should work for me. So why? Because I said it, when you're getting that, if you look here down to the code, I was able to tell it how do I want the data to be arranged for me. So it is going to get the data in the region collected date. You can see the collected date is equal to today. So it's going to use this date time that it picks here to actually run that and give me the rest of those information I need to get. So that's generally how it understand. That's generally how it understand the date time as related to that. So generally, we'll be importing date time, and when you see this type importing date time, and you see me declaring a date time in a particular pattern, like you see here, you can see the way I declare this pattern here. I want it to be year, month, and day. You can see the way it is now. Why? Because that's if I wanted to have hour, minutes, and seconds, I will also include it here, which is exactly what I'm trying to explain to you here. And that's how it will work perfectly in terms of date time. Now that's date time. Then when it comes to math as well, you can also, it is also a built-in math. We also use math as well when we are working, which probably we might be using now henceforth. So in that one, so when it comes to math, so there are several things you need to know. Anytime you put a particular, let's say you put something like a is equals to minus 5, then when you say, for example, when you say print a, let's say print a, so you are going to get these things as minus 5. But anytime you don't want to have minus 5 on it, so you can always use absolute. So you use APS. So this gives you the number in absolute value. So now what does it mean? If you run this particular thing now, so what you are going to get here is 5. So this is necessary. And then you also, when you want to do a power something raised to power something, so you can also do the same thing by, let's say that you go here and then you say 4 raised to power 2. So that means you need to bring POW. This is math. So you are going to use let's say 2 comma 4. So and then when you say print x, so when you run this now, you should be able to have 16, because 2 raised to power 2 is 2 times 2 times 2 times 2. So this with the power, that is math. So that works that one for you when it comes to math. But generally, when we are using math, we say import. Now, math is a modules. So it's modules. So when we say import math, so when you import math, so it comes in here. So if you want to run again, let's say that I say equals to give me, let's say math as, let's say math also the let's say square root of, and then I say square root of 16. So if I say print x, so what happens is that I'm going to have 4, because I say the square root, because I'm importing math. Also remember that you can import math as Lydia. So it means that anytime you go here, type in Lydia, that's what you mean here. So if you run this, the moment they say import math as Lydia, then that means any here you're going to use math. But if you don't import math as Lydia like this, so that means at any point in time here, you have to use math. And then when you run this, and that's going to give you the value of it. So it is called math. So we also have maths, and we can use in different ways. We have Matplotlib, we have also Matplotlib, we have also math ceiling. So math ceiling is to run the number upward to the nearest integer. Matplotlib is to run the number downward to the nearest integer and return the value. For example of what I mean is that if I say 1.6 here, and then I go ahead and say y is equals to yeah, let me use this. So we see here that if I run, let me leave this one since this one comes up. So if I run this now, you see now that if I go ahead and print y, print y, print z. So if I go ahead and run this, now you see that I have round it up to the nearest floor ceiling, that is ceiling like up, and then round it to the nearest down. So this is a way math. So what is working all this is you have already bring in math, and that math has a way like of, okay, this is what you mean, and it automatically pick that up to know that this is what you need to do because you imported the map. So this is exactly how it is done. So when you import math, then that takes care of those things. Now models, you do models and then you arrange them in that order, and then when you arrange them in that order, then there are, when you just import them, there are already something that have been programmed or code that have been written that way to make that kind of instruction or carry out those instructions you have given it. So that's why when you are talking about a modules, so it is a file that contains a set of functions that you want to include in your application. So if you include that, then that's what you can even develop your own. So when we go ahead, I can show you how you can develop your own, and then at any point in time you can say import this. Like for example, if I don't want to show you my password now, for example, when we go to this, I will show you what I mean by that. Like if you see here now that there is a place I put my API, and because I don't want to put my API for you to see it, then I can say import API from kingsley.something import API. So what I do is when I do that, you will not see that API because I've said from here import this, then you won't be able to see the API I'm referring to, but only me knows what I mean by the API because I've defined it somewhere and I can import it from there. So I wanted to show you an example, but I will show you a perfect example from what I mean, and I can show you how I can bring it. Like you see this place, I say your API key here. I have my API key, which I don't want to show anybody, but I've done it in such a way that that's why I said my API key here. So you can see I say API key is equals to API. API is equals to your API key here. The reason is that in case you are using this code, you use your own API. You don't have to use my own. So, and you can see the way I put it up here, API. I have defined my API somewhere and I hide it because I don't want to expose it. So in that way, I have to use it that way. So I'm going to show you how we are going to get that done. Then the other things you can do, which maps need to understand. The other built-in function that's related to map that you also understand. Let's say that we have some numbers like let's say that we have some numbers that we say, let's say open bracket, and we say 3, 6, 9, 18, for example. Here you can now say here, give me which number is the minimum. It's a built-in function. So if you say x here and run this code, it's going to give you the minimum number, which is 3. And you can also say, give me the maximum number here. So remember to put it in small letter. Then if you run it here, you should be able to get the maximum number as related to this. Now what does this? Use it minimum or maximum to get that done. So you can also do the round up number, and you can also do a lot of things when it comes to this as related to that. So this is a way you can manage, a little way you can manage this is a little way you can manage this and then get it done in that particular pattern. Then I wanted to talk about JSON, but like I said, you can make a JSON on its own. We will just use it. It's just simply a syntax for storing a kind of exchange data. So JSON is a text written in JavaScript object notation. So in that one, it is a built-in function that when you call import JSON, you can actually load a data from JSON and then be able to use that whichever way you want it and when you want them. So when we go into using them, we are going to see the way we can use them. Then another thing I want to show us before we start downloading is how do you get package installing. For example, if I am here and I want to use Panda, all of them have a way you install them. So for you to able to know what do you need to install, if I want to install Panda, for example, I can say pip here, pip install pandas, like this. Now if I run pip install pandas, what it will do is that it will start installing. So you can see here it is installing. So because I have already used pandas many times, and you can see it says it's already satisfied. So if I want to install NumPy, for example, then I can go ahead and install NumPy. You can see pip install NumPy, so you can see it downloading here. So anytime you want to install modules, so you can see using this way, you can install it. Then if I want to install letters that we are using in NumPy is a library. So anytime you want to use it, you call it NumPy. So it is called, it is a short name for numerical pi. What I'm trying to say is that you can import a kind of NumPy and be able to use them to do a lot of plugin. For example, because we are going to use NumPy and then we're going to use it extensively. For example, I can just say NumPy. Let me go ahead and say, I can say from NumPy, for example, I can say import random. Now I've imported random, and I can say from Matplotlib, here, .pyplot here, and I can say as, we can say plt. Remember the meaning of this as. I've said something like this, so I've said it before. Now let me just use Seaborn. So let me import Seaborn. All these are modules, so like I said before, and then I can also this is panda, so but let me just use this 3 for now. Then I can decide to say that I want to place SNS, for example, dot, let me use okay, let's just use something since I'm importing. I just want to use this, so let me say I use this plot. Let me just do random. Let's use chi square. So chi square. Then so let's say that the df is equals to 1, and then let's also say that the size of what we are looking at, and let's say 500. And then at the same time we can also, what kind do we look at plotting, and let's say kind is equal to, and let's use KDE, and we can say plt.show. Now the plt.show here is the one that is going to take care of plotting. Random brings us this, which is random gives us this. plt plot Seaborn, that is Seaborn now as CNS, gets these things done for us. So it says from Matplotlib invalid, so it's saying invalid syntax. So let's go back and see what it is. So no, I'm supposed to say import, not from. Sorry. So let's run it again, and then here is saying that models NumPy. So what is NumPy? NumPy. So I didn't type well, so let's check again and see what it gives us. So for example, this is what we have here. So now this is importing models. So you can see now I use 3 here, NumPy, I use Matplotlib, I use Seaborn, and I just wanted to do something of chi square, and then you can see randomly I just put 0 to 500, that is size 500, and you can see here that you can see this just generally. I'm just trying to do like a random plot for you. So what happens, you didn't know how all these things get to plot this, but because these have been defined inside it, you don't need to like say how does this thing works on its own, but randomly that's also get those things done for you. So the models helps you, it has been written by somebody, and what you just need to do is to use that to work anytime you want to work by calling those things, and it does the whole rest of the work for you. So if it is Seaborn, like the way we use Seaborn now, you can also plot using the Seaborn by just like the same way I call import Seaborn, and then you can use that to make a kind of plotting for yourself. So it makes it that I've imported NumPy, so I might not need to repeat it. But let's say that I want to plot use Seaborn, I can just say SNS dot, I can say this plot, then I will say this plot, and I can pass any argument to it. And let's say that I say I need it to plot, I have particular numbers I want it to plot for me, and I can say 3, 5, 7, 9. So you can make this kind of a thing that you want it to plot, and then you can go ahead and say call the Matplotlib and say plot this thing. To plot, you say plt.show. Then that's going to get this thing done for you. plt.show is going to get this plotted for you. So we can have something like that looks like this. So pnlt get it done for you. So you can see here we have 3, here we have 5, here we have 5, we have 7, we have 9. So this just generally, remember that I'm just using a Seaborn to just show you example. So you can use it in other different aspects of plotting, like when you're doing normal distribution, you can use it to plot a different in normal distribution. You can use random when you want to do something that's related to binomial distribution, anything that have to do with all those plotting. It makes things very fast for us and easy for us at the same time. So you can define the size. If you want to see something that goes into normal distribution, you can also make it in that way. Now remember, this was one of the reasons why I said we just need to understand the data, because when we get there we might be a bit looking like we are fast, but we are not fast. So like for example, I want to make a modification of this. Now you see now that I have made an import from random NumPy, import random, from this import plt, from this import Seaborn. But if I want to bring in my data, for example, I want to say let me say the data is Lydia, for example. Then I can now decide to use the type of data that fit in. Like now I want to use dictionary, for example. This time I want to use dictionary. And then Lydia wanted to plot something like normal distribution and binomial distribution, for example. So she can now go ahead and say normal distribution. So let's say the one that goes to normal distribution, and then we have another one again that is not normal distribution. So let's go call it binomial. So let's say it is binomial. Now let's say this particular thing, for example, then we can define how we want it to be. Oh, sorry. Yeah. So let me put it up like this. So you see now that what am I trying to do? I'm trying to use dictionary in this particular pattern. So I'm using dictionary. So in this way, I can say here that random, and then I'll put it. So let me use what it gives me here for this one. And I can also define this one as well. And I can also say the same thing. I can say random as well. So let me go ahead and say random and put it up the same way as well. So because of this, I don't need another one. So I can go ahead and close this up. I don't need this comma bracket. So if you go ahead and say this, plot this kind of thing, the data for me, which I am going to go here, let me remove this, and then say, because the data I defined there is called Lydia, so I can go here and put Lydia on it and say what kind do I need. I will say this kind of thing and plot shoe. So what I'm trying to say is that you see the way we are working on this, so you can have something that looks like this. So you see the way we are putting up like this. So this is the normal distribution and this is the binomial distribution. So when I work on this, and like I said, a kind here, so the moment I say kind here, so you should be able to see that this is what this one is referring to. Now you see, now we don't have much code here, but we're having maybe different output here. So we are just going to dig deep into it. What I want you to know is that here you will start using something like import, and we bring in all our data, different data we are going to use, and when we bring it in, we'll be able to use that to plot a lot of things or do whatever we need to do. So NumPy have its way of working, and those ways of it working is what we are going to be exploring, and then we are going to go in details into Matplotlib. And like I said, we are going to move into Matplotlib, and then we are going to get that done in